Hi, dear friends, I'm Jason from SNS College of Engineering. Today I had to go to the new paper that is Design Analysis of Algorithm. And in this paper, we are first of all we discuss about the basics of algorithm. So, what is called as an algorithm? So, algorithm is a set of rules that must be followed for a computer to perform problem-solving task. So, algorithm is a set of rules and regulations. In a computer, we need any input as well as we need a output. In between, we need a set of rules and regulation. So without rules and regulation, we are not able to process it in a proper, efficient manner. So we need some set of rules and regulation. That set of rules and regulation is called as a algorithm. So how will you start the program? How will you order the inputs is there? What the process is there? What's the exact output? Like this, you need that you have to measuring a set of rules and regulation. So consider example in our English language we need a grammar. So without the grammar we are not able to make a sentence, whether the sentence is a past tense, present tense or future tense. So grammar means that's a set of rules of regulation. How will you speak, how will you write using the past tense, present tense, future or likewise. So the same concept here used in the programming language also, that is called as the algorithm. So without algorithm we are not able to perform a task. So next we have to move to express an algorithm. How will you express an algorithm? There are three ways to express an algorithm. One is the natural language, another is the flow chart, and another is the pseudocode. First we will go to the natural language. What is called as a natural language? In our worldwide we are using a natural language is English language. So that language is called as English. That language is a natural language. So you are writing an algorithm. One of the ways like natural language. So that means you have to start the program. Then you write what are the inputs there, what the process is there, what is the output is there. Next, next I will start the program. If you are using the loop, you have to repeat it. Like this, you have to express in the ordinary English language only. That is called as a natural language. Next, you have to go through the flowchart. Flowchart is a pictorial representation. That is a just you have to mention the diagrams. You know already you know what is called the flowchart. What are the symbols are used in the flowchart? Based on the symbols, you have to draw on a diagram. That is called as a flowchart. This is a pictorial representation. Next, you have to move to the pseudocode. What is the pseudocode? Just you have to go through here. We express the algorithm in the form of annotations and informative text written in the plain English, which is very similar to real code. But as it has no syntax, like any of the programming language, it can be compiled or interpreted by the computer. So this is not a real code; it is a false code. That is called as a pseudocode. Before you are going to write a programming, before that you have to write a rough code. That is called as a pseudocode. So these are the three ways to express an algorithm. One is a natural language, another one is a flowchart, and another one is a pseudocode. Next, we have move the next topic. There are a number of advantages that we already know what are the advantages of algorithm. Easy to implement, easy to write, everything easy to represent as a pictorial, as well easy to represent as a pseudocode. Like this, there are a number of advantages there. But there is some disadvantages there. So what are the disadvantages is there? Just you have to go through that. First point, writing an algorithm takes a long time. So it is kind of time consuming. So writing an algorithm, simple program as well as average program. We are easy to write an algorithm, but where there is a complex problem means we take more time. So that is very time consuming. So one of the first disadvantages is time consuming. Second one, understanding complex logic through algorithm can be very difficult. So complex logic, understanding the complex logic is too difficult. Simple, basic, everything is right. Some logic, simple logic is average logic is okay, but this complex logic is too difficult to understand. Third point, branching and looping statements are difficult to show in algorithm. Exactly. Some branching and looping statements we are too difficult to express in algorithm. So these are the disadvantages we have to face in the design analysis of algorithm. Next, we have to move to the characteristic of algorithm. So what are the characteristic? Well-defined input, first characteristic, well-defined output, clear and unambiguous, finiteness, language independent and feasible. So one is a well-defined input. What is called well-defined input? The input must be defined. Suppose you are performing a one task, the input, first of all, the input must be defined. You need must you need an input. Without input, we are not performing a task. So we need one input, two input, or three inputs, but we need first of all we need a inputs. Next, well-defined output. What's the kind of well-defined output? You must need an output. At least you need a one output. Must you need a one output, not more than one, but you need a one output. So this is a well-defined input as well as a well-defined output. What's the next point? Clear and ambiguous. So here you go through some explanation description. Clear and unambiguous. Each of the steps should be clear in all aspects. At any point of view, the clear step should be clear. That means we need only one meaning of the each and every step. Don't confusing the programmers. Oh, maybe this means that so they are here. This means that. If you're writing a one step, the step should be clear in all aspects. It's only one meaning. Okay. Next, language independent. What is called as a language independent? Algorithm is always a language independent, not a language dependent. Writing one algorithm. This algorithm is used in C language, C++ language, Java language, Python language, any language. So this is called as a language independent. Next, feasible. The algorithm must be simple, not to be confused. In practical way, also everything also it is so it's basically within the available resource. So within the available resource, they need to be executed. So that is the algorithm should be simple. Next, finiteness. Finiteness is the context mean that the algorithm should have a limited number of instructions. So limited number of instruction means countable instruction, not more than uncountable instruction. Within the countable instruction, the algorithm should be there. Next, well-defined output already discussed. It produced at least one output. So these are the some characteristic of algorithm. We are each and everyone go through that. What are the characteristic of algorithm is very important. Next, analysis of algorithm. Why you are analyze the algorithm? It is important because inefficient algorithm can significantly affect the performance of a program. So that's only you have to analyze the algorithm. Improper algorithm can render a result ineffective or correct. So there are a number of algorithms that you implement that algorithm, the performance of the program may be affect. So that's only you have to analyze the algorithm. So what purpose you have to analyze the algorithm? Okay, before that, what is the analysis of algorithm? One is a prior analysis and one posterior analysis. So prior analysis means it refers to theoretical analysis of an algorithm. Theoretical analysis of an algorithm means first of all you are writing an algorithm. Prior analysis. Posterior analysis means after writing algorithm, it refers practical analysis of algorithm. That means you have to implementation the code. It's very important. What is called the prior analysis and another is a posterior analysis. Prior analysis is a theoretical analysis. Posterior means it's a practical analysis. Very important. Okay. Next, algorithm can be classified in various ways. Yes, correct. Algorithm can be classified in various ways. How they are classified? One is implementation method, design approach, and design method. Implementation method, design approach, design method. Clearly, you have to go through that. What are the way to classify implementation method, design approach, and design method. These are the classification of algorithm. Okay. Next, classification by implementation method. So previous slide we have to go through the classification of algorithm. One of the classification is a implementation method. Here we have to go through what are the implementation method. One is a recursion and iteration, exact or approximate, serial or parallel or distributed algorithm. You already have to know what's called recursion or iteration. Already you know exact and approximate and what's called serial or parallel distributed system. Just I end up here. I end up this slide. Next slide we have to discuss each and everything. How the algorithms are classified and how they are implemented. So you have to later we have to discuss about that. Okay. Thank you, students. Thank you.